fill in the VIP table for the circuit below. So we have a battery, a few resistors, and we want to figure out pretty much everything there is to know. Okay, we can do this. So first thing you think about with this is, okay, first way you approach most physics problems, you draw a picture. Check, picture drawn. Next thing you do is you kind of write up the relevant formulas. And in this one, we're going to use Ohm's law. V equals I over R. No, is that right? I equals V over R. There we go. Leading you astray. So current equals voltage over resistance. And then we're going to have resistors in series in parallel. So for series, R equivalent series, you have R1 plus R2. And then for resistors in parallel, 1 over R equivalent parallel equals 1 over R1 plus 1 over R2. We'll see how that works out in a sec. And so what we want to find first, pretty much always, not always, but pretty much always, is the total current. The current that's going to be coming out of the battery. And from there, we can pretty much find everything. So the easiest way to do that is to keep redrawing the circuit until you have one battery and one resistor. So we're going to start by redrawing the circuit. I'm going to combine these two resistors right here into one. So it's going to look something like this. So we have battery, our first resistor, an R equivalent resistor, REQ. This will be the 2 ohm resistor, and then it loops back to the battery. So to combine these two resistors, we're going to have, that's going to be R equivalent. Short answer is R equivalent will be 10 ohms. The way I can know that so quickly is when you have two resistors that are in parallel that are the same resistance, the equivalent resistance is just going to be half of the resistance given. To be more formal about it, you have 1 over REQ equals, in this case we're going to have 20, 1 over 20 plus 1 over 20, which equals 2 over 20, which equals 1 over 10. Therefore you have REQ here. Take the reciprocal of both sides, REQ equals 10 ohms. Add the reciprocals and then take the reciprocal of the sum. So REQ equals 10. Not too bad. So I'm going to cross this REQ out and write 10 ohms. And this is 2, not 20. And so then we're going to redraw the picture one more time. And we have a battery like this, a single resistor. And this one is going to be, since it's in series now, you're just going to sum up the two. So we have 12 ohms. 12 ohms there, and 24 volt battery. Battery stays the same. 24 volt. Convenient that we have everything look so nice. So then we can do Ohm's law, I equals V over R. You might also see V equals IR. And so the current is going to be 24 volts over 12 ohms, which will be 2 amps. And the way to think of amps is a current, and I like to use a hydraulic analogy. And you can kind of imagine as if this 24 volts here is a pump creating pressure, and it's creating a flow of water going this direction. And the water, some of it goes that way, some of it goes this way, and then it comes back around. Well, it's not really water, it's electrons. And it's not electrons moving this direction, it's actually negatively charged electrons moving the opposite direction. But the hydraulic analogy still holds for the idea of instead of voltage you have pressure, and instead of current you have a current of water. So what we want to find then is the current going through this first 2 ohm resistor. So we know we have a current of 2 amps coming out of the battery. And so if it goes out of the battery, the only place it can go is it has to go through this 2 ohm resistor. So we have the 2 ohm resistor right there. And then we can use Ohm's law. So we know the current going through the 2 ohm resistor, 2 amps. Now we can use the Ohm's law, which I wrote as I equals V over R. You can then rearrange that, V equals IR. So the voltage drop across the 2 ohm resistor will be current, which is 2, times the resistance, which is 2, which is 4. So the voltage drop across this resistor is going to be 4 volts. 4 volts. So if you look at, if one of the assumptions you make, which is a fairly reasonable assumption, is this battery means that there's going to be a 24 volt drop between the both sides of it. So you can say this is 24 volts here. You can say this is 0 volts here. There's a difference then between a 24. We just found out using Ohm's law, V equals IR, that there's a 4 volt drop across this resistor. So then we're going to have 20 volts here. We can take this voltage here, and since it's connected by a wire, it's going to be the same as over here, 0 volts. And so the voltage difference between the 20 ohm resistors, it's the same on top and the bottom because they're in parallel, is going to be 20 volts. So the delta V between these will be 20 volts, 20 volts. We can then use Ohm's law again to find the current. I equals V over R. We know that the current is going to be, through the main line here, the current is going to be 2 amps. And then we know it's going to be split evenly because they're the same resistor on top and bottom. So I'm suspecting it's going to be one on top and one on bottom. To be more methodical about it though, we know the voltage drop is 20. So we have 20. We know the resistor is 20. That's 20. So that equals 1 amp. So that's how we can find the voltage drop across the amps through each of the resistors. So 1 amp, 1 amp, which kind of makes sense. If you thought of it as water in a pipe, when you have a branch of 2 pipes, the sum of the water in each pipe would have to be the sum of the water that came out of the pipe. Pretty reasonable as well. So now we've got the top of the table filled out, not too bad. And then power, there's lots of different ways of writing power. The one I remember is P equals IV. And then you can use Ohm's law to kind of rewrite that again. So you can use P equals V squared over R, or that also equals I squared R. Just using the idea of Ohm's law, which applies here. And you can convert to different definitions of power. But the one we're going to use is power equals current times voltage. And so for this, boom, boom, we just do I times V. So this would be 8 watts. This would be 20 watts. And then this would be 20 watts. Again, just P equals I times V. And so that's how I would approach this problem. Hope it did help. See you next time.